First, let's draw our regular octagon, and we'll connect these segments from the midpoints to form this square. We'll call these points A1 and A2. So this midpoint is M1. This segment from M1 is R1. So this point is B1. And up here we have B7. First, we're going to connect the midpoints, M1 and M3. It doesn't look like it in my diagram, but this should be parallel to A2, A3. Let me draw this a little bit better so I can convince you that this is true. I'm going to extend the sides of the octagon so that they meet at this point C at a right angle. I'll replicate that over here. So we have A2 and A3 over here. This forms an isosceles right triangle. Let's let the side length of our octagon be 2. So this distance is 2, which means the leg of our right triangle, CA2, is going to be the square root of 2. M1, M3 are midpoints of the sides of our octagon. So we have A2, M1, and A3, M3 are half the side length, so these distances are 1. So we have triangle M1, M3 is also an isosceles right triangle, which means we also have 45-degree angles here. So even though it doesn't look like it in my diagram, this is 45 degrees. Let's let the distance B1, M3 be equal to x. That's over here. And by the symmetry of our octagon and square, this is going to be the same as the distance from M1 to B7 up here. The side length of our octagon is the same length as the side length of our square. That's 2, so I'll put that in here. Since the distance from C to M1, this is root 2 plus 1. Then the distance from M1 to M3, it's this length root 2 plus 1 times the square root of 2. We're interested in the cosine of this angle here, A3, M3, B1. Let me call this part alpha. That's angle M1, M3, B1. So angle A3, M3, B1 is going to be this 45 degrees plus alpha. So let's take the cosine of both sides, and we'll use our cosine sum formula. That's cosine, cosine minus sine, sine. Both of these are root 2 over 2, so I will factor them out. And I'm going to redraw this right triangle here. Triangle M1, M3, and B1. And this is alpha. Again, we have the distance from M3 to B1 is x, and this distance from M1 to B1 is x plus 2. And earlier we calculated that the hypotenuse has length root 2 plus 1 times root 2. So the cosine of alpha is adjacent over hypotenuse, and the sine of alpha is opposite over hypotenuse. So we'll substitute that in. We have the same denominator, and our numerator is x minus x plus 2. The root 2's are going to cancel. We lose the x's in our numerator, leaving us with negative 2, which is going to cancel with the 2 in the denominator, leaving us with negative 1 over root 2 plus 1. And rationalizing the denominator gives us 1 minus root 2, which is this cosine, A3, M3, B1. The problem asks for the cosine of this double angle, so we can use one of our double angle formulas, and we'll substitute this expression. Now we'll expand this square, multiply by 2, subtract 1, and put everything under the square root. This is equal to m minus the square root of n, and the problem asks for m plus n, which is 5 plus 32, and our answer is 37. If you'd like me to solve any other math contest problems, please leave them in the comments.